Today we will discuss few more examples of the quotient rule. These are the four sums we are going to discuss. Before that, I will request you to try it out yourself, else see the solution next. Example number 1. In this one, we have got two polynomial, one in numerator, another one is in denominator. So, it is in u by v form, u by v form. So, we will apply quotient rule. In quotient rule, it, it is denominator times differentiation of numerator minus numerator times differentiation of denominator by denominator square. Here, when we differentiate 3x square, it becomes 3 into 2x. 3 being constant comes out, differentiation of x square is 2x. And differentiation of 4 being constant is 0. Similarly here, differentiation of x is 1 and differentiation of 2 is 0. After this, the next step is simple algebra. So 3 into 2 is 6x and 1 minus 0 is 1. Now we have multiplied it and after further simplification we are getting the final answer as this. Example number 2. Here we have got in numerator 7 to the power x and in denominator 2x minus 1. Same quotient rule formula we have applied. Denominator times differentiation of numerator minus numerator times differentiation of denominator by denominator square. Differentiation of 7 to the power x is standard formula applied here, 7 to the power x log 7. Here we have already discussed in previous sum. Differentiation of 2x minus 1 is 2 into 1 minus 0. Now we are simplifying this. In the last step, we are taking 7 to the power x common out of this expression. Rest is this expression. Final result is this. In third sum, we have got a little different type of sum. Here in numerator, we have got two expressions with multiplication in between. So we'll treat this as one expression and this as another expression. This is numerator and this is denominator. Now we'll apply quotient rule. So here denominator times differentiation of this whole thing minus numerator into differentiation of this x plus 4. So this part we'll treat as separate one entity and we'll differentiate it once again applying product rule. So here we have applied product rule onto this. So we are getting this log x ddx of x square plus x square ddx of log x after applying product rule. So we are applying product rule inside quotient rule. So if there be product of two terms, so we have to do that also. Differentiation of x square is 2x, differentiation of log x is 1 by x, and here x square x gets cancelled out, so remaining x, and 2x we have kept it out before log x, so 2x log x plus x, and this is another term. It can be further simplified, which is simple algebra. You can try out yourself. Fourth sum. This is also product rule and quotient rule. This is product and this is u by v. So first we will apply u by v, then inside that we will apply product rule. So this is again quotient rule. This is treated as one entity and this is another quotient rule applied. Now here we will apply product rule. Log x ddx of 3 to the power e to the power 3x, e to the power 3x ddx of log x, and ddx of x square is 2x. ddx of e to the power 3x is 3 e to the power 3x. ddx of log x is 1 by x. After algebraic simplification, the final answer is this.